So we have been requested to find the directional derivative of the function. So this is the function. Okay, so we are given the function f x y z. This is the function at the point 2, -1, 1 in the direction of 3i plus j plus 5k. So this is our x point, x value, y value, and z value. So also you can take the vector. This is our vector, which is the vector. It will be 3 and 1 and 5. Okay, so the first approach which we are going to use, first we must find the partial derivatives of this. Okay, we are going to apply chain rule. Okay, we are going to apply chain rule since this is a composite function, which means a function of another function. Okay, so we are going to use chain rule. So for the partial x, which is f subscript x, is equal to, we know that the derivative of any function to the power n is equal to, you take the n and then you multiply everything that is inside the bracket as it is, you close the bracket, you multiply to the power n minus 1. Because it's a composite function, we are applying chain rule. So we are going to multiply again by the derivative of what is inside the bracket with respect to that variable, either with respect to x, with respect to y, or with respect to z, depending on which partial do you want. Okay, so we are going to differentiate that with respect to x. If we differentiate with respect to x, which implies that y is a constant, z is a constant. So we take our 2, that is our 2, and then we repeat everything that is inside the bracket, like what we did here, to the power 2 minus 1, which is 2 minus 1 there is already 1, so there's no need of writing that 1. Multiplied by, which is multiplied by the derivative, which means the derivative of what is inside here with respect to x, since I want partial x. If I wanted partial y, I was going to differentiate with respect to y. Okay, so when you differentiate 2x with respect to x, what do you get? 2. Okay, I just left it 2. So 2 times 2 is 4. And then 4 is multiplying everything. So this is the partial x. Okay, 4 multiplied by that bracket. So from here, we found our fx to be that. Now we are going to differentiate with respect to y so that we can find the partial x, or fy subscript. So you choose how you want to write it. Either you want to write it as partial, or you want to write it as fx or fy. So you choose. If it's partial y, you must just be consistent with what you want to write it. So for here, I've just chose to use this f, fz, fy, fz in place of partial. Okay, so we are going to find the partial derivative with respect to y. So x now is a constant, z is now a constant. So we do what we just said. We take the 2, which is our 2 there. We repeat every function that is inside to the power 2. Then you subtract, differentiating minus 1. It's always minus 1. You multiply by the derivative of what is inside with respect to y. So x is a constant, z is now a constant, just a number. If you differentiate a number, it gives you 0. Okay, so we are differentiating y squared. So if you differentiate y squared, you're going to get 2y. Okay, so 2, which is 2 times 2y from here, it will give you 4y, applying the whole bracket. 2 minus 1 is just 1. Any number to the power 1 stays the same. So now we are going to do the partial derivative with respect to z. Partial z, or fz, is equal to you take the 2, which is 2, multiplied by the function, that is the function, to the power 2 minus 1, which is 2 minus 1, multiplied by the derivative with respect to z. So we are going to differentiate this function with respect to z. What are you going to get? 3z squared. Okay, so if you multiply 2 times 3z squared, you are going to get 6z squared multiplied by the function. So now we've got our partial derivative of x, partial derivative y, partial derivative with respect to z. So next, we are given a vector, we are given a point. So we are going to show you how are these relevant in finding the directional derivative. Okay. So we are going to use the partial derivatives to find the gradient of f. Okay. So gradient of f, this sign denotes gradient. Okay. So gradient of f is equal to the partial derivative in the x, partial derivative in the y, and the partial derivative in the what? In the z. So at point 2, negative 1, 1. Okay, this is our x, y, and z. So we take the partial derivative that we calculated with respect to x. So the partial derivative with respect to x is equals to that. So at point 2, negative 1, you just substitute these points into this function. So it will be 4 multiplied by, that's a bracket, 2 times x, which means 2 times 2, x is 2, and then y, that is our y, negative 1. So it will be plus negative 1 squared plus 1 cubed, 1 cubed. So the answer, if you punch in your calculator, to give you 24. Okay. Now we are going to calculate the partial derivative with respect to y at point 2, negative 1, 1. So it's equals to 4 times y. We already calculated this partial derivative. So 4 times negative 1 multiplied by 2 times 2, 2 times x, plus y squared, which is negative 1 squared, plus z is 1 cubed. So punching everything in your calculator, it gives you negative 24. Okay. So now we are going to calculate the partial derivative of z at that point. So we know it's 6 times z squared, which is z is 1. So 6 times 1 squared multiplied by 2 times 2 plus y is negative 1 squared, z is 1 cubed. Punching everything in your calculator gives you 36. So now we are going to find the vector. So in the direction of 3I plus j plus 5k, which implies that our vector with an arrow on top, you can put round bracket or square bracket, still fine. So it's 3, which is 3, comma, 1 in the y direction and 5 in the z direction. So we want the magnitude of the vector. So the magnitude of this vector is equals to square root of the x component squared plus the y component squared plus the z component squared. So if you add everything, it's going to give you root of 35. That's the magnitude of the vector. So from now we are going to calculate the unit vector. Okay. So our unit vector is simply, we have the magnitude of the vector. So I just represented that u as a unit vector. Okay, just for you to know that now it's a unit vector. This was the vector, then represented by v. Now I put it as a unit vector. Okay, so you can put a notation that does not confuse you. Okay, you can still put u there, it's allowed, but know that this one now it's a unit vector. So how do we find this unit vector? Simply 3 over the magnitude. That will be the component, x component of the unit vector. The y component of the unit vector is simply 1 over the magnitude, which is 1 over root 35. Then the z component of the unit vector is simply 5 over root 35. So our question was, find the directional derivative of f at point 2, -1 in the direction of that. Okay, so this is how we represent d u subscript f x y z, meaning the directional derivative of f, which is this function. So the directional derivative of f, which is this function, where now we are being specific at point 2, -1 and 1. So I want the directional derivative of f at this point. In which direction? So we are going to be using this unit vector in that direction. So what formula are we going to use to find this answer? We are going to take the dot of this, dot product of that, multiply by that. So the dot product of these two will give us the directional derivative. Okay. So that is the information that we have so far. We know the gradient at this point was 24, -24, 36. We calculated that the vector were given in the direction 3i plus j plus 5k. That is the vector. We calculated the unit vector. We said 3 over the magnitude of the vector, 1 over the magnitude of the vector, and 5 over the magnitude of the vector. So this is the information that we have so far. So we want to find the directional derivative of this function, the directional derivative of this function. In which direction? In the direction of that unit vector. This one, directional derivative. In that direction of that unit vector at this point. Okay, so you just dot the two vectors. So this is f, grad f at this point. That is the vector there, the direction. You put it there. You dot product with the unit vector, not with the vector, but with the unit vector. So when you dot the two, it will be, how do we dot it? We say 24 multiplied by 3 over root of 35. So 24 multiplied by 3 over root of 25. Then you say plus the second one multiplied by the second one, plus the third one, which is 36, multiplied by also the third one. Then our final answer, if you simplify everything in your calculator, you are going to get the final answer, which is. So when you rationalize the denominator, we are going to find out that the final derivative is going to be 228. The final derivative of f in the direction of the unit vector at this point will be equal to 228 root 3 over 35. That is if you've rationalized the denominator, which means the denominator has been rationalized. So we are going to get this as the final answer. Okay. So basically this is how we'll be operating online. You just send your work, the problem which you need explanation or clarity. We make a video recording explaining how we find the concepts and explaining the assignment solutions, everything. So just simply screenshot your problems or send as a PDF. We can explain everything for you via online. We send the video recording on YouTube. Thank you guys. Cheers. Take care.